Sure. Here's the revised script without the headings. Opening music fades. Hey everyone, welcome back to the channel. Today we're diving into something that's out of this world. Antimatter. Yeah, you heard that right. Antimatter is real. So what is it? And why does it seem to hate regular matter so much? All right, so here's the thing. As we started to understand how particles work and how they interact with fields and forces, some smart scientists realized there was a wild prediction. What if there's a particle out there that behaves just like an electron, but moves backward through time? Sounds strange, right? That led to the idea of antimatter. Instead of a regular electron, imagine a particle that has the opposite properties, like the opposite charge. For example, an electron is negatively charged, but its antimatter counterpart, the positron, is positively charged. Simple, right? The term positron comes from keeping it positive. So, here's where it gets interesting. If you bring a particle of regular matter and its antimatter twin together, they'll annihilate each other and convert into pure energy. Now you might be thinking, wait a minute, doesn't the law of conservation of energy mean that can't happen? Well, not quite. We've all heard of conservation of energy, right? Einstein came along and gave us a one-stop equation, E equals mc2. This means that energy and mass are interchangeable. So if you take the mass of an electron and a positron, convert it into energy using that famous equation, you get a lot of energy. That's why the smallest amount of mass can generate an incredible amount of energy. Now you're probably thinking about nuclear bombs, right? But the difference here is that matter-antimatter annihilation would leave no matter behind. It's pure energy. With nuclear reactions, there's still some matter left over, just much less of it. Okay, but here's a brainbuster for you. What happens if you have a particle with no charge, like a neutron? If it doesn't have a charge, then how could it have an antimatter counterpart? Well, turns out neutrons are made up of quarks, which do have fractional charges. When you bring in an antimatter neutron, it's made up of antiquarks. And yes, that means there's an antimatter version for every particle out there. Every particle has its opposite. Yes, every one. And that's where things get even crazier. We're talking about an entire antimatter universe. Antimatter might be super rare in our observable universe, but scientists have figured out ways to create tiny amounts of it in the lab. The trick is to take enough energy and convert it into matter, but not just any matter. You need to make a pair, one regular particle and one antimatter particle, to keep the charge balanced. Let's talk about photons, those little packets of light. If you've got a photon with enough energy, you could technically convert it into matter. But here's the catch. It's got to be a high-energy photon to create particles like electrons and positrons. Regular light doesn't cut it. Now here's a mind-bending concept. In the early universe, there was a soup of matter and antimatter particles. As the universe cooled, most of them annihilated, turning back into energy. But somehow just a tiny bit of matter was left behind. And that's why we have a universe with, well, matter in it today. You might be thinking, wait, isn't there supposed to be an equal amount of matter and antimatter? How come we're here at all? Well, it seems that somewhere along the way, the symmetry between matter and antimatter was broken. That tiny fraction of matter that survived is everything we know and experience today, and we still don't fully understand why. So, could there be an antimatter universe out there somewhere? Maybe there's another universe where antimatter reigns and everything we think of as matter is their antimatter. Wild thought, right? Imagine meeting someone from that antimatter universe. If you gave them a hug, would it annihilate you both? Could a coin flip decide whether we find ourselves in an antimatter universe? Maybe, maybe not. But who knows? In the vast unknowns of the cosmos, anything is possible. Anyway, that's all for today. If we don't make another video, well, you'll know what happened. We found antimatter and things got a little out of hand. Don't forget to like, subscribe, and keep looking up because the universe is full of surprises. End music and credits. This version is more streamlined and conversational, ideal for an engaging video script. If you'd like further adjustments, just let me know.